Military bridge construction engineers, what structural solution did you implement using available materials that textbooks would deem impossible? I was deployed with the 20th Engineer Brigade in Afghanistan when we faced a situation that no training manual could have prepared us for. Our mission was to establish a crossing over the Helmand River after insurgents destroyed the only bridge connecting a remote village to the main supply route. The problem? We had equipment for a standard MGB, medium girder bridge, but the span needed was 30% longer than our components could handle, and the nearest additional materials were 4 days away. Local civilians were running dangerously low on supplies, and intel reported enemy movement in the area. Sir, physics doesn't care about our timeline, my platoon sergeant said when I suggested we attempt it anyway. We improvised by creating a hybrid structure using our MGB components reinforced with locally sourced timber and abandoned Soviet-era metal from a nearby scrapyard. The locals showed us a technique for binding wood with a combination of wire and local plant fibers that created tension bands. This violates every principle in the FM 5277, our warrant officer muttered, reviewing our design. But I can't see why it won't work. We integrated the wooden supports in a modified cantilever design, using principles I remembered from a civilian engineering course I'd taken before enlisting. The bridge shouldn't have held according to our field manuals, but the combination of military hardware and indigenous techniques created a surprisingly resilient structure. When the first MRAP rolled across, everyone held their breath. The bridge flexed, more than regulation would ever allow, but held firm. We maintained a 24-hour watch on stress points, making adjustments as needed. That bridge stayed in place for 7 months, well beyond its expected 2-week emergency lifespan. When we finally replaced it with a permanent structure, the Corps of Engineers documented our design. I later heard it became a case study at Fort Leonard Wood for adaptive field engineering under constraint. Sometimes the best engineering solutions come when the manual goes out the window and you trust your training, your team, and the knowledge of locals who've been solving problems with limited resources for generations.